All right, thank you very much. Thank you for still being here. The end of a long day, 2 days worth of brain-bending talks, right? I know my brain is pretty full right now. I suspect yours is as well. I'll try not to keep you too long. But I do want to get your brains working, so I'm hoping that this will promote questions and ideas from you. It's not going to be a practical talk, I'll tell you that now. We've had a lot of really awesome practical talks. This is going to be a bit more meta. But I do want to start off by showing you some code, all right? Let's look at some code. Here is some code. It's a picture of code. This is in the code base of deoxyribonucleic acid, or DNA. And it is literally a picture of code. It is a photograph of DNA. This is the famous photograph 51. It was taken by Rosalind Franklin, the X-ray crystallographer. And it was thanks to her work that we were able to decode the code base of DNA: adenine, cytosine, guanine, thymine. So base 4, unlike the binary base that we work with computers, it's 4 simple building blocks. And from those 4 simple building blocks, we get all life on planet Earth. Everything. Mammals, birds, fish, trees, all of it comes down to DNA, all sharing the same underlying code base. From very simple building blocks, we get immense complexity through the process of evolution, through natural selection. And it's a long, slow, messy process, but it's quite an amazing process. Again, from simple building blocks, such complexity arises. And what's interesting over time is you look towards, this incredible variety of life on planet Earth. When you start to see commonalities, you start to see certain trends emerging in biology. A trend towards specialization, right? A species getting really, really good at something. I mean, we tend to think of human beings as being like the most highly evolved species, but the truth is every species is the most highly evolved species because it's still around, right? Every species is extremely highly evolved for its environment. So we tend towards specialization. Ubiquity, we try and spread as far as we can, and life is all over the world, right? Everywhere. And interestingly, cooperation is something we start to see in the animal kingdom, where a group can accomplish more than an individual. So this is how species evolve over time, through natural selection, long, slow, messy process, relying on errors in that code base that then gets selected for by the environment. Now, as human beings, we've managed to hack the system. We've managed to get one up on natural selection. And we can augment ourselves not through this long, slow, messy process of evolution, but through technology. That we can find a way to augment our capabilities. Like, here's a piece of technology. It's the Australian hand axe, millions of years old, and existed all over the world, very ubiquitous, very specialized. And this allowed human beings to augment their limbs, right? To have a sharp cutting tool at the end of a limb without having to wait for natural selection, evolution, to select for a sharp cutting tool at the end of our limb. So a classic piece of technology, we get to augment ourselves and thereby changing the entire world around us. That we shape our tools, thereafter the tools shape us. And when you look at the history of tools, you see this repeat over and over, that we've managed to augment ourselves with amazing tools. Here's an amazing tool, more recent one than the Australian hand axe. This is the pencil. It's a great piece of technology. It's got a great affordance. You know exactly which bit you're supposed to use. It's got a built-in progress bar, which is very useful. And it's got undo. You always want to have undo. And looking at tools like this, you start to see an interesting correlation with the world of biology, because you start to see this trend towards specialization, ubiquity, and cooperation. So specialization, the pencil does this one thing really well. Ubiquity, there are pencils all over the world. You can go to pretty much any country, you will find a pencil in roughly the same shape and form. And cooperation. No human being can make a pencil. No single human being. There's a classic book by Leonard Read called I, Pencil, and it's told from the point of view of the pencil. And it describes, all the work that went into, getting the graphite and felling the trees for the wood and carving the wood and putting it all together. And no single human being can do that. It requires cooperation. And pretty much all of our technology requires cooperation. No single human can just create a piece of technology that's going to be as useful as something we create together. I mean, you can try, but you probably have a bad time. Like Thomas Thwaites, he's an artist in the UK. You might have seen his most recent project, which was where he attempted to live like a goat for a year. But before that, he had another project called the Toaster Project, where he attempted to make a toaster from scratch. Literally from scratch. He wanted to smelt the steel, he wanted to make the plastic, he wanted to do the wiring, everything from scratch. He had a hard time. It was prohibitively expensive, and it worked for maybe a second before, completely blowing the place up. So this cooperation seems to be intrinsic to technology. So you've got these traits in biology, right? Specialization, ubiquity, cooperation, and these traits in technology, specialization, ubiquity, cooperation. And it would be easy to think that, oh, well, they're clearly the same system, right? But no, they're very, very different. Like I said, with biology, it's evolution through natural selection. It's long, it's slow, it's messy, it's kind of wasteful, but it works amazingly well. Whereas with technology, there's a design in mind, right? We imagine the thing and then we make it into being. Nature doesn't do that. Nature doesn't imagine an ostrich or an elephant or a fish, right? That just happens to be the end result of evolution through natural selection. There is no designer there. Whereas with technology, we can imagine something and make it so. My favorite example of a school of thought around technology, where you picturing what you want to exist in the world and then making it happen, is a school of thought called Chindogu. Literally means like a curious tool. And there's ideas behind this philosophy of this tool, which that these things should be not exactly useful, but not altogether useless. I'll show you some examples of Shindogu. Like these things, you should look at them and think, that's crazy, but it's like, is it crazy? That actually, I can imagine it. It's like, that's stupid. Well, actually, it could be pretty useful. I mean, why not? Little umbrellas to keep your shoes dry in the rain. It makes sense. Why not harness the kinetic energy of your toddler to keep the floors clean, right? And if you don't have a toddler, that's fine. It works on other things too. But but these things are obviously ridiculous, and it's very hard to imagine them actually being used in the real world, right? Like, so I found this device in a Chendogu book from 1995, with some kind of like stick that you could put a camera on so you could take self-portraits by yourself. I mean, no one could actually imagine using that in the real world. But all of these things, from Ashwalian hand axes to pencils to Chindogus to toasters, they're all classic examples of technology as we imagine it, where there's a human being and there's a piece of hardware. That's the technology. And the human being is augmented through the hardware. Now, something happened in the 20th century that changed this slightly. There was an extra layer introduced, and that's software, in between the hardware and the human. So now the human can interact with the software interacts with the hardware, and vice versa. Looking back, let's say the last 100 years, I'd say the pinnacle of this trifecta of hardware, software, and human working together would be something like the Apollo landings, right? By the way, I just have to point out this picture here. Seeing as we were just looking at selfie sticks and talking about selfies, I would like to point out that this picture is one of the few examples of an everyone elsey. This is a picture taken by Michael Collins, and in the picture there's, Buzz Aldrin and Neil Armstrong, and every other human being alive on planet Earth, except Michael Collins. It's an everyone else. But anyway, the Apollo landings, right, required incredible hardware like this and incredible human beings, right, those astronauts doing it, but it also required incredible software. It's hard to imagine it being possible without the onboard flight software written by Margaret Hamilton, creating entire new fields of software design in the process. And over time, right, this trifecta of human and software and hardware, I'd say has evolved so that, in a way, the hardware becomes less and less relevant over time, and the software becomes more important, and it's that interaction between human and software that's really defining our world. This idea of design dissolving in behavior, that the hardware literally becomes irrelevant. Now, that idea of making hardware irrelevant, in a way, was kind of at the heart of Tim Berners-Lee's vision for the World Wide Web, right? That the hardware shouldn't matter. He's working at CERN, right, in the 1980s. This is the thing about CERN is an amazing place, right? Fantastic work being done there. It's also kind of amazing that anything gets done because it seems like there's no hierarchy there. People just do what they want, but somehow amazing work happens. And you can't dictate to the scientists at CERN. You can't say everyone's got to use this kind of computer, right? People will use whatever they want to get the work done. So this was the problem that Tim Berners-Lee was attacking, right? How do we get people to share information when they're using all kinds of different systems? Now, this is something we take for granted today, that if you make a web page, it doesn't matter whether your visitor is on the Mac OS or Windows or Linux or Android or iOS, that they could still be able to access what you've created. But it's quite revolutionary at the time, right? To decouple the hardware, to make the hardware irrelevant. Now, the World Wide Web is this classic example of technology that sits upon the technology that's come before. I mean, this is true of every piece of technology. Right? You can't have, and obviously there's technology that exists since the World Wide Web that relies on the World Wide Web to exist, right? You can't have Twitter or Facebook without the World Wide Web, but you can't have the World Wide Web without the internet. You can't have the internet without computers. You don't get to have computers without having electricity, and that requires industrialization, and on it goes, right? This happens all the time through the history of technology, where certain steps need to happen first before possibilities are even available to you. Stephen Johnson, the author, he talks about this idea of the adjacent possible, like why you couldn't have a microwave oven invented in 15th century Holland, because there's too many other steps that need to be invented first before you get to the microwave oven. Well, it's certainly the case with something like the World Wide Web, right? All these other steps need to happen first. And when you look at the history of technologies like this, in retrospect, things can seem inevitable, right? It can seem like, oh yeah, of course we got the World Wide Web because we had the internet, and of course we got the internet because we had computers. And there's a certain amount of inevitability to these things, but the details aren't inevitable. So something like the internet probably was inevitable after the creation of computers, but the exact nature of the internet we got, that wasn't necessarily inevitable. That's something I want to come back to. This idea of what's inevitable and what do we get to shape and control. So the World Wide Web itself is built up of multiple technologies, basically 3 building blocks, right? You've got the protocol, the hypertext transfer protocol, you've got URLs for identifiers, and you've got this simple HTML format. So Tim Berners-Lee comes up with this 3-piece technology suite. And it turns out that creating the technologies isn't the hard part. Not to belittle the work done here, right? They're fine, the technologies. But actually the hard work is convincing people to use the technologies that you've created. How do you convince the people working at CERN to use HTTP and URLs and HTML? And when it comes to this question of convincing people to use a technology or convincing people to change their ways, I'm always reminded of Grace Hopper, Rear Admiral Grace Hopper, one of the co-creators of COBOL and the inventor of the compiler, without which computing would be very, very different indeed. And she was always frustrated by trying to get people to change their ways. She used to say that, the most dangerous phrase in the English language is, "We've always done it that way," right? And what she said was, humans are allergic to change. And I think she's right. Humans are allergic to change. Now, her reaction to that was, she would go on to say, I tried to change that, right? She would try to find ways to get people to think about things differently. She used to have a clock on her wall that ran backwards, simply to emphasize that it was an arbitrary mechanism, and you could change how you told the time. So Grace Hopper acknowledges that humans are allergic to change. She tries to change that. Tim Berners-Lee also realizes humans are allergic to change, but rather than fighting it, he decides to go with it. And that's why each one of the building blocks of the World Wide Web are built upon existing pieces of technology that people are already familiar with. Right? So HTTP is built upon a TCP/IP, right? So building upon the work of Bob Kahn and Vint Cerf. And URLs work with the domain name system that John Postel has already put so much work into. And HTML, this format, is very much based on an existing format in use at CERN at the time. It's a form of SGML, Standard Generalized Markup Language. So the scientists at CERN were already creating documents in SGML, and Tim Berners-Lee is trying to convince them to create documents in HTML. Well, he simply took SGML wholesale and pretty much copied it. If you were to look at documents written in CERN SGML at the time, you would have seen elements like this. Elements that we recognize as being part of HTML today. Rather than inventing things from scratch, Tim Berners-Lee just took them wholesale, made them part of HTML. In fact, you could pretty much take an SGML document, save it with a .htm file extension, and it automatically was an HTML document. And then over time, we get to add to HTML. Right? So with HTML5, we've got all sorts of new semantic elements. So we could demark parts of our documents and give them more semantic richness. But where it gets really interesting and powerful, of course, is when we add to HTML elements that come with behaviors wrapped into them, elements that are quite powerful, things like video and audio and canvas. Right? What's interesting about the design of these elements is that when they started to appear, we could begin using them even though not every browser supported them. Because each one of these elements, canvas, video, audio, picture, take a list, they all allowed you to put fallback content in between the opening and closing tags. So you could start using them, and the newer browsers would get the benefit of canvas or whatever it happened to be, and the older browsers would render whatever they saw in between the opening and closing tags. And that's how we could get to, build the web and not have to wait for every browser to support this stuff. That's not an accident. That's very deliberate. I mean, the canvas element is a classic example. That started life as a proprietary element created by Apple. And other browser makers saw it and went, ooh, we like the look of that. We'll have that, please, which is how a lot of standards actually get made. But when it came to the standardization process, Canvas was changed from being a standalone element like image, where it didn't have a closing tag, to being an element that has an opening tag and a closing tag. And that was a deliberate choice so that people could put fallback content in between the opening and closing tag for the older browsers that didn't understand Canvas. It's a very deliberate design decision because it was driven by design principles. There are design principles for HTML, right? The idea that these things should be designed so that web content can degrade gracefully in older or less capable user agents, even when making use of new elements, attributes, APIs, and content models, right? It's not an accident that those elements are designed that way. This is from the HTML design principles. I'm kind of a sucker for design principles. I like them a lot. I actually collect them. I've got a website, principles.adactio.com, where I collect design principles from personal design principles, organizational design principles, software, hardware, everything. I kind of just throw them in there. Even Chindogu. Chindogu has design principles. You can find them here. I think the reason why I'm fascinated by design principles is because of where they sit kind of in the process. In any endeavor that human beings are creating, you begin with the goals, right? You've got the vision of what it is you're trying to accomplish. And then those goals, something like making hardware irrelevant, those goals influence the principles, like the HTML design principles. And then those principles result into patterns, like the HTML elements that behave the way they do, right? So you've got the goals influencing the principles, influencing the patterns. And that's how we get these HTML elements that are immensely powerful. And I remember when these elements are being introduced and people are trying to decide, is it time to use them or not? When is it safe to use these powerful new elements? We kind of do what we always do with any powerful technology in a web browser. We ask ourselves the question, well, how well does it work? Right? Which is a really good question to ask. You're wondering whether to use the technology. First question, well, how well does this technology work? And that will influence your decision. And it's a good question, but I don't think it's the most important question. I think a more important question than how well does it work is to ask, how well does it fail? And this is where you find things like HTML and CSS really shine, because they fail really well. Canvas, video, audio, all that stuff. They were designed to fail well, and so that made it easier for us to adopt them. Right? Deciding whether or not to use these technologies became a lot easier. So this question, I think, is a really important one to ask when evaluating technology, rather than simply how well does it work. I'll give you another example. Let's say you're trying to evaluate some CSS that's in some browsers. Well, what you might do is you go to caniuse.com, and you see, how well does it work? How well supported is it? And what you see in Can I Use is always going to be this mixture of red and green, right? But the green tells you how well it's supported in browsers. The red doesn't actually tell you anything. The red doesn't tell you how well does it fail in those browsers that don't support it. So in this case, I'm looking at CSS shapes. So let's say I use CSS shapes. I'm using it on my website here, right? And I have this text wrap around the circular image there. So this is how it looks in a browser that supports CSS shapes, one of the green browsers on Can I Use. But how does it fail in a browser that doesn't support CSS shapes? Well, I get this. The text simply goes in a straight line and doesn't wrap around. I can live with that, that's fine. I would say it fails very, very well. And therefore, I can start to use it, even though there might not be as much green on that can I use page as I'd want. So simply looking at the red and the green doesn't give you the whole story. I think asking this question, how well does it fail, really starts to get at whether you want to start using a technology or not. So let's use that. Let's use that question, how well does it fail, as a lens to examine some technologies you've been hearing a lot about, past couple of days, past 6 months, past year, the kind of buzzwords of web development. I'll pick just a few. First of all, service workers. Patrick was just giving a talk on service workers. So who's heard of service workers? Okay, who's using service workers? All right, interesting. Far many people have heard of it than are using it, so most of you are evaluating this technology, trying to decide whether it's worth using it or not. Service workers, I won't go into the detail of how they work, because Patrick did that in his talk, but they're just, they're kind of weird. I don't know quite, because they're scripts, they're JavaScripts, but don't treat them like you would treat your normal JavaScript files. That would be bad. It's like it just happens to be written in JavaScript. You write this script with instructions, and that gets installed on the user's computer like a virus, but in a good way. And then that script can intercept requests from the browser to that domain and do whatever you've instructed it to do. It's very powerful. Best way I can describe it is a service worker lets you do a man-in-the-middle attack on your own website, right? So you can decide to do things. Don't go out to the network, just look in the cache, or write your own recipe. You get to do all this powerful stuff. And if the network fails for whatever reason, you can do things like, show a custom offline page. That's like the bare minimum you could do with a service worker is have a cute offline page. The Guardian have a really nice thing they do with their service worker. If you're on the train trying to read an article, but the network connection is down, you don't get the article, they give you a crossword puzzle to play, which is kind of cute. But then there's no-brainer stuff you can do with service workers, like, I'm going to put my CSS and my JavaScript and my icons into a cache, and I'll tell the service worker that if there's any request for those things, don't go out to the network, go straight to this cache and grab them there, and you get these enormous performance benefits, right? So that's service workers in a nutshell. But yeah, how well does it work if you're going to actually use it? It does what it says on the tin. It doesn't do anything for free. I'll say that about service workers. You have to write the instructions. You have to tell it exactly what to do. People are sharing their service worker recipes, so that's good. But you have to get your head around how it works. You have to understand promises. You have to get to grips with fetch and cache and all this stuff. But if you do that, yeah, it works pretty well. But here's the browser support. So you go on Can I Use, and you see some green, you see some red. And you think, there's a lot of red there, right? But as we saw with CSS shapes, the red doesn't tell us anything. Because the real question we need to ask is, how well does it fail? How well do service workers fail? And this, I think, is where the genius of service workers shines through, in how they've been designed. Because if a browser is visiting your website for the first time, whether it supports service worker or not, same thing's going to happen. It's got to make that request to the server. It's got to get some things. One of those things might be a service worker that then gets installed on the user's machine, and then from then on can intercept requests and do great caching stuff and show a custom offline page. But the first time anyone visits your website, every visitor is a non-service worker supporting visitor, right? So because of that, you literally can't make service workers a linchpin of your site. You can't make a site depend on service workers. You can really only add service workers as an enhancement to sort of turbo boost your site. And that's a good thing. Because then it kind of doesn't matter how much red there is on Can I Use. Even if there was only one browser that supported service workers, it's still worth doing it for that browser. You don't penalize any of the browsers that don't support service workers. There's no harm done to any of the browsers that don't support service workers. So it's a classic case of the red columns in Can I Use not really telling you whether you should use a technology or not. You really have to ask this question, how well does it fail? So I would say, when it comes to service workers, really well. Service workers fail really, really well. All right, let's look at another buzzword. What about web components? That's another one. Who's heard of web components? Who's using web components? The real deal now. Kind of similar numbers. Lots of people heard of it, only a few people using it in production. All right, so what are web components? it's kind of an interesting one. Like service workers, it's not just one technology. With service workers, you have to get to grips with fetch and cache and maybe notifications and all this cool stuff. Well, web components is really just an umbrella term for a bunch of different specs. So like custom elements. We've heard about custom elements a few times, right? And the sinisterly named Shadow DOM. Not as scary as it sounds. And there's other bits. There's HTML imports and templates and all this stuff that works together. So web components is kind of an overarching umbrella term for a whole bunch of different APIs. And the idea, the dream of web components is that we can break out of this cycle where in the past, when we want new additions to HTML, new powerful features, we kind of have to go cap in hand to the standards bodies and the browser makers, say, please give us this element, please give us this new feature. And it takes time, it has to be spec'd, it has to get into the browsers, and we test it and so on. The idea with web components is that if you want an element to exist, you're going to just make it, right? So I want to create entirely new elements. You just go ahead and do it. All these common patterns you keep coming up against, but that don't have native HTML semantics, you just create them. And these are examples of custom elements, where you just make shit up, right? You notice the commonality with them all is that they have to have a hyphen. This is kind of a long-term agreement between the browser makers and web developers that there will never be a native HTML element that has a hyphen in its name. So it's almost like a safe namespace. As long as you use a hyphen, you can create any element you want. Well, okay, that's great, but if you go ahead and create, a mega menu element, you've basically just written span, right? Because by itself, it doesn't do anything. The reason why we use things like canvas and video and audio is that the browsers understand what we mean when we type canvas, video, and audio. The browser doesn't understand what we mean when we type mega menu. So we have to tell it what we mean. And this is where the other bits of web components come in. So we might link off, this is the HTML imports part, link off to a file that then contains our instructions for what to do with this element, how it behaves and how it's styled. Now, this is where the dream lives. Because the idea here is that the CSS and the JavaScript contained in this file is encapsulated. It doesn't leak out, right? You can style this component and only this component, right? You won't get that leakage. Everyone can, CSS is broken. You won't have that problem. The dream is real. And this is basically what, things like React are trying to solve. Encapsulation, modularity, having things contained, self-contained, which makes them reusable. Right, so you could write a mega menu component, and I want to use it on my page. I can just drop it in there, right? Self-contained components. Pretty powerful. How well does it work? Well, there's a lot of moving parts. Like we said, there's about 4 different specs involved in web components. And if we go to Can I Use and look at the browser support for just one of them, let's say custom elements, this is version 1 custom elements, yeah, not great, right? There's a lot of red on there. But as we've seen, that doesn't tell us anything. The red doesn't tell us anything. What we really need to ask is, how well does it fail? That's where things get interesting with custom elements and web components. Because the answer to the question, how well does it fail when it comes to web components is, it depends. As with so many things in web development, it depends. It depends how you're using the technology. So if you're creating a custom element, let's say I'm creating an image gallery, I could use it like this. I could take my cue from the way that canvas and video and audio and those elements were designed and say, okay, the way this element's going to work is I put the fallback content in between, and that's actually the content that I then bootstrap up and turn into this amazing image gallery. Like if the browser supports all the web components pieces, then this gets turned into a swishy carousel with lovely transitions and neat gestures, right? But if the browser doesn't support the technology, well, you still get the images in the image gallery, right? So if you use web components like this, they fail well. But what I tend to see more is web components used like this. Opening tag, closing tag, nothing else, and all of the logic and the behavior and the styles and the content living off in that JavaScript world, right? So everything's kind of been put into JavaScript as a single point of failure. This is a shame, I think, but the good news is it's early days, right? I mean, we're very early on in the web component story. So we could kind of set the the mood here. And we could say that we're not going to do it like this, that we're going to provide fallback content, that we're going to design them in a certain way. Maybe we need to have design principles for web components because they're very powerful, right? They're part of, giving us access to these low-level APIs comes with a lot of responsibility. I mean, the great thing about web components is that they give us web developers power that previously was only in the hands of browser makers. But the scary thing about web components is that they give us web developers power that was previously only in the hands of browser makers. So it's kind of up to us. I get worried when I see some of the poster children for web components, like the Polymer project from Google, right? That's a great collection of web components, and they build demo sites to show it working, and they've actually built a full shop online using the Polymer web components. But this is what the HTML looks like of that page. An opening body tag, closing body tag, and there's one shop app. Open tag, close tag. And everything else is in the JavaScript. This is not going to fail well. But it's possible to write web components in such a way that they do fail well. So I think it's up to us to set the course here. The jury is still out. We can decide what the future is like here. Now, so both service workers and web components, they share a lot of things in common. Like I said, it feels like they're umbrella technologies, giving us access to low-level APIs. In the case of service workers, they give us access to fetch and cache, and notifications, background sync, right? All things that browsers do deep in the guts. And web components, we're getting access to that low-level stuff. And we saw earlier about Houdini, right? Again, being given access to the low-level workings of the browser. Well, this is all part of a, I guess, school of thought, which is the extensible web. This idea that we developers should be given the DNA of web browsers. And then we create what we want, and the good stuff then finds its way back into the spec, right? That's the theory. There are goals and principles behind this. There is a manifesto. There's an extensible web manifesto. I think it'd be really interesting to see how it plays out. How do we respond to being given so much power? Do we abuse it, or do we live up to our responsibilities? It's exciting. So the extensible web is not a technology. The extensible web is a term. It's right, just words. But words are very powerful. Words are very powerful when it comes to the adoption of technology. Ajax is just a word. Ajax is a word for technologies that already existed, but it was a nice, snappy, easy-to-say word, right? And that helped the adoption of the technology. Responsive web design. It's a phrase, it's a great phrase, but it describes technologies that already existed. Ethan's genius was wrapping up those things into one handy term that people could get behind. Here's another term you've probably been hearing a lot about, progressive web apps. Right? Patrick was talking about this right before this talk. And again, it's not a technology, it's an umbrella term for a bunch of technologies. Who's heard of progressive web apps? Who's using progressive web apps in production? Similar numbers, yeah. So again, evaluating this technology. Should I be using progressive web apps? Well, you have to break it down. Progressive web apps, like I said, it's just a term. If you have a website that's running on HTTPS, which is anyway a prerequisite for having a service worker because of the amazing power of service workers, and you also have this manifest file, which is just a JSON file, not to be confused with the app cache manifest file. No. This is just a much simpler thing where you just list out, here are my icons, here's some metadata about the site, right? Then you have a progressive web app. That's pretty much it. I mean, there's another list of good things to do on the original blog post announcing this. This is a term, progressive web app is a term created by Frances Berryman and her husband Alex Russell. And it's basically saying if you take your vitamins, if your website behaves well, it's performant, it's running on HTTPS, it's got a service worker to handle offline stuff, and you've got this manifest file so that operating systems know where your metadata is, then you've got a progressive web app. And Google in particular have been kind of dangling a carrot here, where if you have these conditions fulfilled, and a visitor on Chrome for Android will be prompted with this prompt to add to the home screen. If they visit, I think, more than 2 times in a certain amount of time, it's like they've demonstrated engagement. And then they'll get prompted to add it to their home screen, and from then on it can behave exactly like a native app, which is incredibly powerful, right? But when you saw the list of things that qualified to be a progressive web app, it's actually pretty straightforward. HTTPS, a service worker, and the manifest file. Like, there's no reason not to do those things for any website. Right? Like I said, service workers, go ahead and use service workers, even if they're only supported by one browser. Right? HTTPS, that's just good practice anyway. And this manifest file, well, it sure beats shoving a load of meta crap in the head of your documents, right? So any website really could be a progressive web app. Which is why I get so worried, again, when I see the poster children for progressive web apps. I see stuff like this. The Washington Post built a progressive web app. This is what I see if I come and visit the Washington Post with a browser that supports service workers, supports all the technologies of progressive web app, right? But it happens to be a desktop browser, and I'm being turned away and told to revisit with a mobile phone. Oh, how the tables have turned. It did not seem that long ago when we were being turned away from mobile, right? And come back with a desktop browser. But either way, didn't we solve this problem? Isn't this what responsive design was about? That you don't have separate websites for devices. You don't have a separate subdomain for M.dot or progressive web apps or whatever. You just turn your existing site into a progressive web app. It's not magic, right? I'm worried, frankly, about the framing of it as progressive web app. I have seen people say, oh, I didn't investigate that technology because I'm building a content site, and I assumed progressive web apps was just for apps. Any website can be a progressive web app. I've used it on all sorts of stuff. Like this one, huffduffer.com, maybe qualifies as an app, maybe. But like I've got a community website, and that's a progressive web app. It fulfills all the criteria. My blog, a progressive web app. It's on HTTPS, service worker, manifest file, 100 out of 100 on Lighthouse. Hey, let's call it a progressive web app. Put a book online. Now a book is an app, apparently. Or even a single-page site about design principles can be a progressive web app. So I'm concerned that in our rush to become on par with native and to be as good as native apps, that we end up sacrificing the huge variety of the web, which is that we can do more than just apps. We can do all sorts of stuff, and all of those things can benefit from these technologies. None of these websites should not be progressive web apps, right? If the limit of our ambition is to be as good as native, that's setting the bar too low for the web. Right? The web is incredibly powerful. Native doesn't have URLs, instant distribution. That's amazing. And yet here we are in this rush to just be as good as native. We're thinking too small. So progressive web apps, the terminology, just understand what's in there, right? And realize if you're building any kind of website, it can be a progressive web app. When it comes to any of these technologies, I think a good question to ask when you're evaluating the technologies is this: who benefits from this technology? Who's going to benefit from it? And when it comes to web technologies, I would say there's roughly two camps of people who could possibly benefit from a new technology. That's developers and users. Now, 9 times out of 10, a technology benefits both. Right? There's no opposition. It's good for developers and it's good for users. Great. But there are situations where we have technologies that benefit the developer, but maybe at a price to the user. Or vice versa, a technology that benefits the user, but the developer has to pay a price. I would say service workers are an example of that. Service workers have clear benefits to the user in terms of performance and user experience, but the developer's got to learn this new technology, learn how it works, investigate these APIs, right? There's a burden on the developer to give the user the benefit. Now, personally, I'm okay with that. Because it kind of goes back to one of my favorite design principles, and yes, I'm such a nerd, I have a favorite design principle. Again, from the HTML design principles, my favorite is the priority of constituencies. In case of conflict, consider users over authors, over specifiers, over theoretical purity. I agree with that list. Now, we're pretty high up in that list. We're the authors, right? But consider users over authors, over implementers, that's the browser makers, over theoretical purity. I like that. And that's how I tend to approach technologies when I'm evaluating them. I'm willing to take the hit as a developer if there's a direct benefit to the user. But when we're talking about web technologies, I think we need to make a distinction here. I'm trying to think of the best way to phrase this distinction. And the best I come up with is that there's kind of inward-facing tools that we as developers use, the tools that kind of sit on our computers. And then there's the outward-facing technologies, the stuff that tends to be in web browsers. and they directly impact the users, right? They're kind of, so you got the inward and the outward facing. Now you could say that any technology that benefits a developer, therefore benefits the user, right? Because the developer is working better, working faster. But I mean directly impacting here. So as an example, or examples of inward-facing technologies, I would say we've got build tools, and we've got version control, we got, preprocessors, all this kind of stuff. They sit on our computers, they help us work faster. At the end, though, what they output is still going to be HTML, CSS, and JavaScript, okay? Now, when it comes to choosing these technologies, evaluating these technologies, should I use this tool or not? I think whatever you like to do. Basically, go crazy. It's totally up to you. Because there isn't a direct effect on the end user, I think do whatever you want, right? And I might disagree. I might use none of these tools, all of these tools. You might use some, none, all. Doesn't matter, right? There's no direct effect on the end user. Use whatever you like. But I don't think we should apply the same criteria when we're looking at the outward-facing tools. The tools that have a direct effect on the end user. Now, these are tools that benefit us as developers, JavaScript libraries, CSS frameworks, but because they directly touch the user kind of pays a tax. The user is paying a tax for our developer convenience. And now I think we need to be a bit more cautious in evaluating these technologies and simply saying, hey, whatever works for you isn't good enough with these technologies because there is that direct effect on the user, and we should consider users over authors, in my opinion, right? Now, when it comes to these tools, the user-facing tools, there's all sorts of questions to ask when you're evaluating the technologies. What's the browser support like? That's going to be important, right? How far back does browser support go? What's the file size like? How much of a tax is the user going to get? How much will they have to download here? I'm talking about the client-facing stuff here. It's really interesting, actually, that Ember and React and Angular have kind of shifted the pendulum back towards server-side rendering as well as client-side, so you can kind of get the benefit of both worlds, turn them back into being inward-facing tools, so you can have your cake and eat it too. But yeah, for the client-facing stuff, the browser support, the file size, the community. How quickly would I get an answer if I have a problem, right? What's the community like? These are all really good questions that you should be asking of any user-facing technologies. But I don't think they're the most important question. The most important question to ask of a user-facing technology is, what are the assumptions? What assumptions have been baked into this technology? Because I guarantee you they are there. What ideas are represented by the technology? One place you could look for the answer to this is in the design principles. Does this particular project have design principles? That's a good place to look for the assumptions, right? The principles will be based on the goals of the project. Really what you're looking for here is, you're looking for a tool that has a philosophy that matches your own philosophy. Because remember, a tool is supposed to augment us, help us work faster. And if you have a tool made in code that matches your own philosophy, you'll work with that tool, right? You'll work faster. But if you have a mismatch between your philosophy and the tool's philosophy, you're going to butt up against it. You'll be fighting it every step of the way. This is why you can get into the situation where you got one group of developers going, yeah, this framework rocks, and another group of developers going, no, that framework sucks, right? And they're both right and they're both wrong, because it depends entirely on the philosophy of the developer using the tool and the philosophy of the tool. I guarantee you there are assumptions baked into every piece of technology created by humans, and code is no exception. Code inevitably reflects the choices, biases, and desires of its creators, whether we intend to or not. And when we talk about opinionated software, the truth is all software is opinionated, right? At ClearLeft, we open sourced a project called Fractal, which is for helping people build pattern libraries. And the whole design goal, principles behind it, was that it should be as agnostic as possible, right? It shouldn't make any assumptions about build tools or template languages or anything like that. Turns out it's really, really hard to make something that's truly agnostic. I mean, every time you write a line of documentation to show an example, you're going to have to favor one language over another, for example. And now you've made a choice, and you've betrayed a bias there. It's very, very hard to make technology that's truly agnostic. But I don't want to make it sound like the technology is created with these biases, and then that's it. There's nothing you can do to fight them, right? You have to use the technology the way that the creator of the technology intended. That's not necessarily true either, right? As William Gibson said, the street finds its own uses for things. The history of technology is littered with hardware that was intended for one purpose and was actually used for completely different purposes. Like when Alexander Graham Bell created the telephone, he thought that people would listen to concerts at a distance. And when Edison created the gramophone, he thought that people would record one side of a conversation and send it off, and then the other person would record the other side of the conversation. And those technologies ended up being used in completely the opposite ways, right? So there's lots of examples throughout history of a technology created for one thing actually really finding its purpose somewhere else, despite of what was embedded into the technology. I'll give you an example from the 20th century, from Hedy Lamarr, star of the silver screen in the first half of the 20th century. She was married to an industrial arms dealer in Austria, and after the Anschluss, she would sit in on the meetings with the Nazis, and she was paying attention. Nobody paid much attention to her. Anyway, she managed to make it out of Nazi-occupied Europe, which is a whole adventure in itself. She makes it to America, and she wants to do her bit for the war effort, particularly after some of the losses at sea in the North Atlantic. And she wants to help the Navy with their guided torpedo systems. Because what they have is a very crude radio-controlled torpedo for trying to destroy U-boats. The torpedo is broadcasting on one frequency, the controller on the same frequency. If the Germans manage to block that frequency, they've blocked the effectiveness of the torpedo. So what she came up with, together with a composer named George Antheil, was this system for changing the frequency regularly. So both the torpedo and the controller are changing the frequency at the same moment. And now it's a lot harder to block that radio transmission. Okay, so what does a technology created in World War II for guided underwater missiles have to do with us today in the 21st century? Well, I'm guessing right now you've got devices with you that have technologies like Bluetooth or Wi-Fi or even GPS. And all of those technologies make use of this frequency hopping created by Hedy Lamarr. So is technology neither good nor bad? Not neutral. There's this idea that the history of technology has this inevitability to it, that maybe technology is the driving force of history and we're just along for the ride, right? There's this idea of technological determinism, right? That this stuff is coming and there's nothing you can do about it, so, it's the future, take it, because there's no point trying to resist, right? Whether it's in the world of Frontend and it's the latest JavaScript framework that everybody's using and you better get on board that train because it's irresistible, or it's out in the real world and it's, automation and self-driving cars and AI and whatever. I find it feels disempowering, that feeling of inevitability, that there's nothing you can do about it. It's the future, take it, right? I think this idea of technological determinism, it kind of finds its apex in this idea of the technological singularity, right? It's kind of the rapture of the nerds. It's an idea it's borrowed from cosmology. The science and science fiction writer Vernor Vinge coined this phrase, the technological singularity. The idea being that in the cosmological singularity, you've got this point of matter that's so dense, right, it collapses space-time, and nothing can escape the event horizon of the black hole that's formed, not even light. So the point is that from outside the event horizon of a black hole, there's literally no way to observe what's going on the other side of the event horizon. Now, with a technological singularity, the idea is that technology will develop so rapidly and so fast that we will hit an event horizon. And from our perspective today, it's literally impossible for us to predict what's on the other side of that event horizon. But when I look back at the history of human civilization, I wonder if we've had a few singularities already, like the agricultural revolution. When human beings changed from being hunter-gatherers to being farmers, that's a change that was so different. Life was so different on the other side of that event horizon that it would have been impossible for nomadic peoples to imagine that lifestyle. And when we shifted to industrialization, right, the way we live our lives is fundamentally changed, and that would be impossible for an agricultural society to imagine. And now we're probably living through a third singularity around information. But here's the thing about those previous singularities. They didn't wipe out what came before. Agriculture didn't wipe out hunter-gatherers. There's still hunter-gatherers in the world today. And industry didn't wipe out agriculture. Agriculture still exists. We still have industrialization even as we live through this information age. So it's not that each technology replaces the one before. It's that things tend to coexist. Kevin Kelley is a technology writer who writes very provocatively titled books, things like What Technology Wants and The Inevitable, which makes it sound like he's a technological determinist. But it's a bit more subtle than that. In one of his books, he talks about this idea that he says, no technology has ever gone extinct. And that sounds like a ridiculous claim. That's ludicrous. And he doesn't mean that it's sitting in a museum somewhere. He means literally somewhere in the world today, somebody is using a technology that existed once. And you can try and refute the claim. Please do. But it's actually hard to do it. So these things just continue to exist. It's not that they get wiped out by new technologies. So Kevin Kelley sounds like he's being, a technological determinist, but actually what he says is certain things, the broad picture is inevitable, but we get to control the details. We do get to shape our future. In the same way I said that, something like the internet was inevitable, but the internet we got wasn't. That depended on the people designing it, right? So looking at Kevin Kelley and his impressive facial hair, you might be forgiven for thinking he's Amish. He is not, but he would describe himself as Amish-ish, because he has spent time with the Amish, and he admires the Amish a lot. And it turns out they get a really unfair rap. People think that the Amish reject technology, and it's not true. The Amish are steadily adopting technology at their pace. They are slow geeks. And I think we could be all a little more Amish-ish. I don't mean in our dress sense and facial hair. I mean in how we question technologies and the pace at which we accept the technologies, that we evaluate them by asking questions. Questions like, yes, how well does it work? But more importantly, how well does it fail? By asking of the technology, who benefits here from this technology? And perhaps most important of all, asking, what are the assumptions baked into the technology? Because I don't think that the future needs to be this inevitable tide washing over us that we have no power to resist. I think we do have the power. Because when I look back at the history of human civilization, I don't see something that's driven by technology. I see history driven by people. Remarkable people, it's true, but people nonetheless. And you know who else is remarkable? Well, you're remarkable. So, your attitude shouldn't just be, hey, it's the future, take it. I think it should be, it's the future, make it. And I'm looking forward to seeing the future you make. Thank you. Do we have time for questions? Brilliant. I would love it if you had questions.
But before that, I would like to ask you to remain for a few minutes after we finish the questions, because we have prepared something to say a warm goodbye to you. So, let's get on with the questions. Who would like to take the mic?
Oh,
Hi. My question is, which generations are the most luckiest, if we can say that, the past generations or the future generations?
The most what now?
The most lucky.
The most lucky. Oh, every generation is the luckiest and the unluckiest. That's an interesting question. I sometimes wonder if I'm living at the best time, right? This is the perfect time to be alive because we got the web and we got all this stuff. And then I wonder, no, I want to see the Mars colonies. I wish I'd been born 100 years later. And looking back at my own life, my own generation, I feel like there's this period of 10 years where I was just killing time before the web was invented. Like maybe I was born a bit too soon. I don't know what I would have done if the web hadn't come along. But this idea of generations and their relationship to technology is a really interesting one. There's Douglas Adams had a quote about this, that when you're young, technology is just what's around you. It's normal. It's just the world. When you're in your 20s, technology, anything new, is exciting and cool, and you investigate it. And then by the time you get to the 40s, it's scary, and you don't want anything to do with it, right? So there is this interesting idea that different generations are maybe more receptive to technology. I don't know if I can ever answer that question of yours, but I will point out that we can fall into the trap sometimes, true in technology, true in the arts, true in everything, of thinking that everything's already been done, right? That we've got it figured out. You know, this happened in the world of science in the 19th century. It's like, yeah, we pretty much just need to cross the T's and dot the I's, but we've pretty much got science figured out now, and then whole new worlds of science opened up to us. And it can be easy to think that, you know, the big advances have already happened in technology, whether it's on the web or whether it's out there in the world. And actually, every generation gets to have its epochal events. But as to which generation is the luckiest, ooh, I don't know. I mean, I feel pretty lucky that I got to be there when the web came along, but on the other hand, I had to live through the 80s, and they were pretty shit. So, swings and roundabouts, you know. Another question. Did we have one over here? Did I see a hand go up, or no? I guess not. Okay, other.
Great, thank you. Yeah, thank you so much. Great, very provocative and thought-provoking.
Thank you.
I do think we all know one technology that is dead. It's called Flash.
Well, you say that.
No, just so I've been a web developer for a long time, since the 90s, and what you were talking about, the event horizon, rings to me. It sort of helps to describe a lot of my own experience in having to pivot in technologies. Do you see currently sort of a shift happening within the web industry itself for front-end developers? I wonder if you could talk a little bit about sort of your own journey and where you see things going.
Yeah, yeah, great question. I think what's interesting, when you've been around for a while, like we old fogies have, you start to see cycles repeat, right? You see things that look like new problems are actually resurfacing things we had in the past. Like, so when, you know, the iPhone comes along, it's like, oh my God, you know, we have to deal, we don't know the screen size, and the network connection is really bad. But if you were building websites in the 90s, you were already thinking of that kind of stuff, right? So these things cycle around. I remember when Ajax came around, and suddenly it was like, oh no, the back button doesn't work in browsers, and bookmarking is really hard because we didn't have the history API, right? And I was thinking, hang on, all those problems sound familiar. Oh yeah, Flash, we have to deal with the same problems. No back button, no bookmarking. And if you really want to go back, frame sets, right? Really good. So no, but you start to see some of these same ideas cycling around. So it's interesting today whether you would consider what's happening now in the world of front-end development like an epochal change, or is it just refinements? Like, is there anything fundamentally different between what we're doing? And you know, at the end of the day, HTML, CSS, JavaScript. Get better HTML, better CSS, better JavaScript, but still, you know, the way web browsers work fundamentally is still the same. And yet, it seems like we're going through this huge change in how we work together. You know, the JavaScript library ecosystem, the way we think about CSS and JavaScript. I honestly can't tell. I can't tell whether this is a fundamental change in our ecosystem, or just, yeah, we're just refining things at this point. I think it does help to step back from whatever industry you're in and kind of try and get a better longer-term perspective, or step outside your workplace and see how other people are building things on the web. Because it's easy to fall into that sort of tunnel vision of thinking everybody on the web is building like this. I mean, you'd certainly be forgiven for thinking that, you know, if you're reading Twitter or Medium and these things, you think, wow, everybody is building their websites with React these days. But actually, if you look at the numbers, you know, it's still vanishingly small compared to just regular old-fashioned, you know, websites. So trying to get some perspective, I think, can help. But I'm certainly not going to try and predict or say, you know, this is the future, this is where we're headed, because that's a mug's game, right? I think if you've been around as long as we have, then you avoid any kind of prediction, because you'll only make yourself look foolish in the long run. Do we have another question?
I was wondering what is your opinion about net neutrality and what is going on right now in the US?
Yeah, well, net neutrality is absolutely fundamental.
What maybe are the consequences and what we could do about that?
Yeah, great question. Here's the thing where I think the distinction between the web and the internet becomes important. A lot of time we use the terms interchangeably. And people talk about, oh, the web is, you know, under fire. And actually, the web is doing okay, but as we saw, the web is built on top of building blocks, and the most important one being the internet. And if the internet goes to shit, then the web's going to go to shit along with it. So I feel like I kind of have to go down the stack, because my love is for the web, and that's where I concentrate my efforts. But yeah, it's the internet that's under threat with things like net neutrality. As what we can do about it, fight it. I mean, the battle's pretty much lost where I live in the UK. Traffic shaping is part of life, and we've got a government that's actively trying to, you know, not understand technology. I leave it. It's pretty sad to see what's happening in America as well, but I guess it's up to the citizens of each and every country to do their best. Here's a worrying thing, though. We had a net neutrality battle, what was it, 2 years ago? You know, particularly because of the States. And a number of companies stepped up and threw their weight around. Google, the Wikimedia Foundation, you know, turning their sites black and giving messages to people saying, you know, write your congressmen, you know, this be bad. And I feel really conflicted about that, because on the one hand, I completely agree with their position. I'm like, yes, good, write your congressperson and, you know, sort this out. On the other hand, that abuse of power by an organization to influence politics sets a really bad precedent. I'd rather it wasn't up to Google, Facebook, and those companies to be the agents of change, and I'd much rather it were us individually. Now, we can use those tools. This kind of gets onto another thing of using the tools for the purposes other than which they were intended. And we can use tools provided by Google and provided by Facebook to you know, activate politically and organize politically, and that's great. But when I talked about technology having biases and stuff built in, they're the biases in terms of how they're used, right? They want to be used in a certain way. There's biases at the point of creation. Technology is an amplifier, right? Technology amplifies things, which is what some people use as an excuse to say it's neutral. Technology is just amplifying what was already out there in the world. So bad behavior on the internet is simply an amplification of bad behavior that's already out there in the world. And it's true, technology does amplify at the point of use, but technology also amplifies at the point of creation. So even when you use tools created by a corporation like Google or Facebook for, you know, political ends that maybe are at odds with that corporation, you're still feeding the beast, right? Google and Facebook are still getting value from you in their using of their tools. So this is going above the stack, to above the internet and net neutrality to the web layer, but I'm very much in favor of more decentralization around the web. If you look at the web and its building blocks, all the best things about it are decentralized. The fact that you don't need to ask anyone for permission to put a website up. You don't need to ask anyone for permission to create a URL, right? Completely different model to the App Store. But over time, we've kind of centralized on these power hubs, right? The Googles, the Facebooks, the Microsofts, the Apples. I'd rather see some that original vision of the web, that it's chaotic and it's messy, but it kind of works. I'd like to see a return to that. And there's various, you know, ideas around that. There's the interplanetary file system format, which is kind of a peer-to-peer idea for net traffic. There's the indie web movement, which is dedicated to the now revolutionary idea that you should have your own website, right? That's actively a disruptive act in this day and age. So I'm tending to concentrate my efforts still on the web stack rather than down at the technology stack, the internet stack. And yeah, we got to fight for net neutrality every step of the way, but I feel really conflicted about large corporations swinging their weight around, even when I agree what they're swinging it around for. Do we have any questions from people who aren't dudes? No? Oh, should I get off the stage and take my laptop? Or? Oh, yeah, sure. Okay, yeah. So we're going to change over the computer for the closing remarks, and I can still answer questions, though. So
I have two in mind, but okay. What about you, Melanie? Have this?
Thanks for a really interesting talk, Jeremy, as always. I'm curious what you think about the likely blurring of technology and humanity in the future. It seems that I'm diabetic and I'm wearing something that's plugged permanently into my arm to monitor my glucose levels. for example, I think we're going to start to see more of that kind of merging of body and technology. Do you think that might change where the event horizon exists in some way?
So this is was I was referring to this idea of design dissolving in behavior, that the hardware literally becomes invisible, and it's embedded in us, that we live inside computers and we have computers inside us, but we don't even think about them as being computers anymore. We think about them as being houses and cars and implants. On the whole, I mean, that is great, but this is where the issue of security really starts to come to the fore. And we've managed somehow to sidestep this issue in our industry, the technology industry in general. I mean, other industries, they've got rules, they got regulations, there's things you can't do, or you have to go through clinical trials before doing things, and none of that exists for any of this technology. Partly because, again, what I was saying about politicians not understanding technology. There's dangers with technology becoming invisible. Is that we as humans, we use our senses, we use what we can see around us, what we understand, with the scale that we understand. So when something is invisible, it's hard for us to imagine its impact. Climate change being a classic example, right? You can't point to climate change, and yet it's probably the most dangerous thing facing humanity at the moment. And with technology, there's equal dangers. I'm reminded of a story that I think it was Clay Shirky was talking about, where there was a town where they were thinking about installing traffic cameras. And this was to catch people speeding through intersections. And they had a town hall meeting about this, and there was a debate and there was a vote. And they decided to, on balance, the benefits they got from the cameras in reducing fatalities was worth the surveillance that would go with it. So that was a good example of technology, in that case hardware, being discussed and being debated. Now here's the thing, about a year or two later, a firmware update comes out for those cameras, and now those cameras can do facial recognition. Now those cameras are networked and can start to do more powerful things. And there's no town hall meeting about that, right? There's no debate about that because it's invisible. And a lot of time when we talk about the future technology, we tend to talk about these physical things and the dangers, the benefits that they'll bring. And it's more the invisible stuff, I think, that's potentially more life-changing, could bring more benefits, but also more dangers if we're not careful. So paying attention to the invisible things, I think, will be important, but will be very hard for us as humans because we tend to pay attention to cars, drones, wires, right? Things we can touch, and it's hard to evaluate software in the same way we evaluate hardware. Any other questions? Are we ready to have the closing remarks? All right. Well, thank you very much for those questions. They were great.